trig integrals, and in particular ones that involve tans and secants. So they're just like the ones that had sines and cosines, except now we can't really use this formula anymore because it doesn't apply. So what we're going to do is divide both sides by cosine squared and get tan squared x plus 1 is secant squared x. It's an identity you may have seen before. This is how we can derive it. So, okay, so how do we actually do it? Well, you're really going to see this integral in two flavors. One case in which both powers are odd, the other in which they're both even. Okay, if they're both odd, what we're going to do is try to manipulate the integral such that we have some stuff in terms of secant, and then we have a secant and a tan x out front, and then we're going to use this because we know what the antiderivative of secant tan x is. We're going to use that in a u sub in order to actually compute the integral, or actually transform it into a polynomial integral using u sub, and then do the integral. If they're both even, then we're going to try to make it look like some stuff concerning tans, and then a secant squared out front, and we're going to use this differentiation rule in order to use in our u sub in order to solve the integral. So let's see how that actually plays out. So if we have tan to the 6th x, secant to the 4th x, they're both even. So what I'm going to try to do is get a secant squared x by itself. The way I'm going to do it, simple. I'm going to say, okay, well, I'm going to give myself, I'm going to write this again, except I'm going to break up the secant to the 4th x as secant squared x and secant squared x. So now, this is exactly what I want. I have a secant squared x dx. Now, all I need to do is get this stuff to be only in terms of tan. Okay? So the tan is already in terms of tan, so the secant, I have to transform it to look like tan. Well, I can do that using this formula very easily. I can go back and forth from tans to secants very easily. So this is going to look like the tan stays as tan to the 6th x, and then the secant squared x, instead of secant squared x, I'm going to use my formula to write tan squared x plus 1. And then we have the secant squared x dx. Now I can use u sub very easily to do this integral. My u is going to be tan, and my du is going to be secant squared x dx. And that's the reason I had secant squared x out front, because I knew my du was going to involve secant squared x. So now it's very easy. Right, u to the 6th, and then I have u squared plus 1 du. And you can actually do it, and it's very easy. But for the interest of time, I'm not going to do it. So what if they're both even? I'm sorry, what if they're both odd? Well, the idea is still the same, but we're going to do something that we did last time. We don't like odd powers. We like when our trig functions are in even powers, because that's how, whenever we see them, they happen in even powers. So what I'm going to do is pluck off a tan and pluck off a secant and put them out front. So I'm going to write tan to the 4th x secant to the 6th x times tan x secant x dx. So now what I need to do, all I need to do, now I have it perfectly such that I have a tan x secant x dx, just like I want it. Now all I got to do is make sure the rest of this stuff is only in terms of secants. The reason I want that is because if I can get it to be in terms of secants, then I can make secant my u, and I already have my du. Okay? So I'm going to go ahead and, before doing it, I'm going to think about what I'm going to do. So again, I want everything to be in terms of secants. So I need to get rid of the tan to the 4th x and somehow write it in terms of secants. I'm going to go back to this formula and say, well, tan to the 4th x is just tan squared x all squared, right? And tan squared x is just secant squared x minus 1. So I'm going to write secant squared x minus 1 all squared, secant to the 6th x, and then secant x tan x dx. Now I'm ready to do my u sub with my u being secant x and my du being tan x secant x dx. So now I'm just going to go ahead and substitute. It's going to be u squared minus 1 all squared. Then I have a u to the 6th. Then I have a secant x tan x dx, which is going to be my du. And again, this is a very, very easy example to do. So as you can see, it's never hard. You just have to be careful that you choose the right sort of route to go. If they're both even, then your u is going to be your tan, and your du is going to be secant squared. But if you have two odds, then you're going to pluck off a secant, pluck off a tan, and then use this guy with secant being your u and secant tangent being your du. So there you have it. That's trig integrals concerning tans and secants.